We have seen what happens when current is flowing through a straight conductor in our previous lecture. Now let us see what happens in a current carrying conductor with a slight twist. Over here we place the conductor in a way so as to resemble a loop. So let us see what happens in a current carrying loop. Over here we find that the conductor has been placed in the shape of a loop and on a plastic board with two holes in it. Now when there is no current flowing, the iron filings are randomly placed. Now what happens as soon as current starts flowing? Observe closely. The moment current starts flowing in the current carrying loop, a magnetic field will be generated and the pattern of the magnetic field will be given by the iron filings, as you can see. Over here, the iron filings are no longer randomly generated, but they have arranged themselves in a particular pattern around the current carrying loop. So the schematic of the experiment is shown over here. Now over here we have considered a cardboard on which the current carrying conductor is placed in the shape of a loop. Two holes have been considered through which the conductor passes through the cardboard. Now through the placement of the iron filings on both the sides, we are able to find out the pattern of magnetic field. Now how can we find out in which direction the magnetic field lines are pointed? Now we can do either of two things. We can use the right hand thumb rule. So let's see what happens if I use the right hand thumb rule at this end. Now if I consider the pen as the current carrying conductor, I can see that current is moving in the upward direction. So my thumb will be pointing in the direction of current and my fingers will be encircling the direction of the magnetic field lines. So it will be in this direction or in this direction. So as you can see, the field lines are as obtained. Similarly, if I apply the right hand thumb rule at this point, I will find that current is flowing in the downward direction. So I consider my thumb in the downward direction. So now you will notice that my fingers are encircling in this direction. So this direction gives me the direction of the magnetic field lines. As you can see, this is the direction of the magnetic field lines. Now you might be wondering that this method is quite inefficient because at both the ends you have to apply the thumb rule. There is a chance that you might forget to invert your hand at this end. So in order to make things simpler, there is a different rule to follow. Now let's see what that different rule is. Now when current is flowing through this particular phase of the loop, we find that it is flowing in the anti-clockwise direction. Now when it is flowing in the anti-clockwise direction, with the help of a compass needle, we can easily find out the direction of the field lines. We will find that the field lines are coming out from this particular face. That is, at the face from which we see when current flows in the anti-clockwise direction, we will find that the field lines are coming out of it. Now, what have we studied about field lines? We have studied that field lines come out of the north pole of a magnet. So we can say that when current is flowing in the anti-clockwise direction, that loop is the north pole. Or in other words, that face of the loop acts as the north pole. Conversely, if we consider the other face, now with the other face, current will be flowing in the clockwise direction. Now again, if you consider a compass needle being placed at different points to map the direction of the field lines, you will find that the field lines enter this phase of the loop. Now what have we studied about field lines? We have studied that field lines enter at the south pole of a magnet. So we can say that that phase of the loop where current is flowing in the clockwise direction, that phase acts as the south pole of the current carrying loop. Now this entire thing can be visualized in a much simpler manner. When current is flowing in the anti-clockwise direction, consider the letter N. Now, when it is flowing in the anticlockwise direction, consider both ends of n and place arrows so as to indicate the anticlockwise direction. As you can see, I have already done it for you. Now, since this indicates anticlockwise direction in the letter N, N stands for north. So this represents the north pole. Similarly, where current is flowing in a clockwise direction, consider the letter S. Again, consider both the ends of S and draw two arrows pointing outwards. So as you can see, these two arrows depict the clockwise direction and the letter S stands for south. So this indicates the south pole of the current carrying loop. Now the same polarity which we had looking at a particular face, that polarity can be reversed if we simply reverse the direction of current. Because we have seen that when current flows in an anti-clockwise direction, it is north pole, and in clockwise direction, it is south pole. So let us say that we are standing at and looking at the same face. We are looking at the same face of the loop without changing our position. Now we can get different polarity on the same face if we simply change the direction of current flow. Over here, it is anti-clockwise, thus north. Over here, simply by changing the direction of current flow, we have made it the south pole. Thus, on reversing the direction of current in the loop, we can get opposite polarity at the same face of the loop. So this is how a current carrying loop behaves.